So this video is going to be all about vectors. So to start off with, we're going to be looking at breaking vectors into components, finding the magnitude of vectors, and then how we can add vectors. So starting out with breaking vectors and components, let's first start by considering some vector here, vector r, that is some angle of theta above the x-axis. We can talk about the x component, r sub x, and the y component, r sub y. Looking at this by itself as a triangle makes this a lot easier, and so the first thing we can do is we can apply the Pythagorean theorem in order to see that the magnitude of r squared is going to be equal to r sub x squared plus r sub y squared. Then what we can do is we can look at how we can break this into components. R sub x is going to be equal to the magnitude of r times cosine of theta. R sub y is going to be equal to the magnitude of r times sine of theta. Putting our coordinate system back and looking at unit vectors, where the unit vector x hat denotes the portions of the vectors that are pointing in x, and the unit vector y is the unit vector that tells you what vectors are pointing in the y direction. We can see that r vector is going to be r sub x times x hat plus r sub y times y hat, which in this case says that r vector is equal to the magnitude of r times cosine of theta x hat plus the magnitude of r times sine of theta times y hat. Now, we can look at another situation here where instead we're going to be measuring this vector r relative to the positive y-axis with this angle phi. The same process still applies here, and so we can say r sub y is along the y-axis, and then we have the component r sub x in the negative x direction in this case. So taking away our coordinate axes, we can see a triangle again, and we can apply the Pythagorean theorem here by saying the magnitude of r squared is going to be equal to r sub x squared plus r sub y squared. And now we can look at how we can break this into components. So remember, we said that because we were defining the positive x direction to be to the right, r sub x is actually negative, so this is going to be minus magnitude of r times sine of phi, and r sub y is going to be the magnitude of r times cosine of phi. Putting our coordinate system back and showing our unit vectors x hat and y hat, we see that r vector is equal to r sub x hat plus r sub y hat. In this case, that says that r vector is equal to minus the magnitude of r times sine of phi times x hat plus the magnitude of r times cosine of phi times y hat. All right. So now we're going to look at how we can add vectors together. And so in order to do that, let's consider some vector A that's going to be pointing similar to the first r vector we had, and some vector B that's similar to the one that we had for our second r vector. Now, in order to do this, I'm going to claim that the vector C, which is going to be the sum of the two vectors, can be defined such that C sub x is going to be equal to A sub x plus B sub x. C sub y is going to be equal to A sub y plus B sub y. And C vector is going to be C sub x hat plus C sub y times y hat. So let's see how we can do this. So the first thing we're going to do is we're going to move our vector B so that the tail of it is at the tip of the vector A. And we can define the vector C graphically here by connecting the tail of A to the tip of B. Now let's look at how we can form the components of C vector. So we have A sub y here and B sub y. Putting in C sub y, we can see that A sub y plus B sub y is equal to C sub y. And then we can do the same thing for the x direction. So A sub x is at the bottom here. Then we could put in B sub x and then C sub x. And we see that C sub x is equal to A sub x plus B sub x. Now we have to be careful here that because B sub x is pointing to the left and we're defining the positive x direction to point to the right, that means that it's actually going to be negative. So we can see in the end that C vector is equal to A vector plus B vector by saying that C vector is equal to C sub x hat plus C sub y times y hat. And that's it.